calculate the primary line and phase currents of a three-phase 1000 kV ampere 11/0.4 kV delta-wye transformer connected to a Y three-phase unbalanced load, given ZOL equals J0.5 per unit, CB equals J0.8 per unit, and ZC equals J0.3 per unit on a 1 MV base with sequence impedance X0 equals zone equals X2 equals J0.1 per unit, and source voltage at primary valve equals 11 at 0 kV, VBC equals 11 at negative 120 kV, and VCA equals 11 at 120 kV. In the star points of the transformer and three-phase load are solidly grounded. We proceed as follows. Firstly, convert the impedance values to per unit. We have ZOL per unit equals J0.5 per unit, ZB per unit equals J0.8 per unit, and ZC per unit equals J0.3 per unit. Secondly, convert the line-to-line voltages to per unit. VAB per unit equals 11 divided by 11, which equals 1 per unit. VBC per unit equals 11 divided by 11 times e to the power of negative 120 degrees, which equals 1 at negative 120 degrees per unit. VCA per unit equals 11 divided by 11 times e to the power of 120 degrees, which equals 1 at 120 degrees per unit. Thirdly, calculate the positive sequence components of voltage and impedance. For n equals 1 per unit plus 1 at negative 120 degrees per unit plus 1 at 120 degrees per unit, all divided by 3, which equals 1 per unit. So n per unit equals J0.1 per unit. Fourthly, calculate the positive sequence current. Ione equals VON divided by the sum of ZA per unit, CB per unit, CC per unit, and zone per unit, which equals 1 per unit divided by J0.5 per unit plus J0.8 per unit plus J0.3 per unit plus J0.1 per unit. This equals 0.75 minus J0.25 per unit. Fifthly, calculate the negative and zero sequence currents. I2 equals I0 equals 0 since the system is solidly grounded. Sixthly, convert sequence currents to phase currents at the primary side. I equals Ione times e to the power of negative 120 degrees. IB equals Ione times e to the power of 120 degrees. IC equals Ione. Seventhly, calculate the primary line currents. I minus B equals I minus I, which equals 0.75 minus J0.25 per unit minus 0.75 minus J0.25 per unit times e to the power of 120 degrees, which equals 1.5 per unit. I minus C equals I minus I, which equals 0.75 minus J0.25 per unit times e to the power of 120 degrees minus 0.75 minus J0.25 per unit, which equals 1.5 per unit. I minus A equals I minus I, which equals 0.75 minus J0.25 per unit minus 0.75 minus J0.25 per unit times e to the power of negative 120 degrees, which equals 1.5 per unit. Therefore, the primary line currents are I minus B equals 1.5 per unit, I minus C equals 1.5 per unit, and I minus equals 1.5 per unit. And the primary phase currents are I equals 0.75 minus J0.25 per unit, I equals 0.75 minus J0.25 per unit times e to the power of 120 degrees, and I equals 0.75 minus J0.25 per unit times e to the power of negative 120 degrees.